So what's up guys? In this video, we'll talk about pulse width modulation. So what is pulse width modulation? Pulse width modulation is used to control amplitude of digital signal in order to control devices or applications requiring power or electricity. PWM is the way to control analog devices with an digital output. Another way to put it is that you can output a modulating signal from a digital device such as an MCU to drive an analog devices. It's one of the primary means by which MCU drives analog devices like variable speed motors, dimmable lights, actuators, and speakers. The perceived output is changed by varying the duty cycle. The duty cycle is the comparison of on versus off. Pulse width modulation has many uses because it allows us to finely control different electronic devices. An example would be to apply full voltage to the motor for a fraction of seconds or falls the voltage to the motor at intervals that made the motor change its speed. In reality, the voltage is being applied and then removed many times in an interval. The length of time that a pulse is in a given state, high-low, is the width of a pulse wave. Device that is driven by PWM ends up behaving like the average of the pulse. The average voltage level can be steady voltage or a moving target. So this is how the pulse width modulation works. As you can see, when the graph goes up, it will give voltage to the motor that will make it spin. And when it goes down, there is no voltage going to the fan. So if the pulse is driven high 25% of the time, then the duty cycle is 25%. In this case, the fan is only receiving voltage 25% of the time. If you want the fan to spin faster, then you can change the PWM output to a higher duty cycle. The higher the frequency of high pulses, the higher the average voltage and the fan will spin faster. If you will manually switch on and off an electric fan with 50% on and 50% off in every second, you will notice that the fan will spin slower than when it is 100% on all the time. The duty cycle can change to affect the average voltage that the motor experiences. The frequency of the cycles can increase. The pulse can even be increased in length. This can all happen together too. But in general, it is easier to think of as either duty cycle increasing or frequency increasing to increase the speed of the motor. So that is how pulse width modulation works. If you like this video, please don't forget to hit the subscribe button. Thanks for watching.